Hi guys, this is Puneet and you are watching Knowledgist. मोस्ट अवेटेड सेंट्रल बैंक ऑफ इंडिया की जोन बेस्ड ऑफिसर्स की वैकेंसीज आउट हो चुकी हैं गाइस। और जो हमारे पास स्पेशल बैच हैं वो भी हमारे शुरू हो चुके हैं। तो आप चाहें तो ज्वाइन कर सकते हैं। स्पेशल बैच हमारा 2025 शुरू हो चुका है, स्पेशली सेंट्रल बैंक ऑफ इंडिया जोन बेस्ड ऑफिसर्स के लिए गाइस। बात कर लेते हैं थोड़ी सी इंपॉर्टेंट डेट्स के बारे में। अगर अभी आपको नहीं पता है तो जाके आप रजिस्ट्रेशन कर लीजिएगा। ये 21 जनवरी 2025 से शुरू हुआ है रजिस्ट्रेशन और इसकी लास्ट डेट है 9 फेब 2025 का। जो मोस्ट प्रोबेबली डेट कही जा रही है एग्ज़ाम के लिए वो मार्च 2025 के कहीं ना कहीं शायद एंड में रहने वाली है। और इंटरव्यू के लिए बाद में डेट्स अनाउंस करी जाएंगी। अब अगर आप बात करें इस क्लास के बारे में, खास तौर पे इस क्लास के लिए गाइस, तो ये क्लास रहने वाली है आपकी कंप्यूटर नॉलेज की। इंपॉर्टेंट है जानना आपके लिए। और कंप्यूटर नॉलेज यहाँ पे हमारे पास आने वाला है 20 क्वेश्चंस ऑफ 20 मार्क्स गाइस। ओके, सो वी आर गोइंग टू हैव 20 क्वेश्चंस विद 1 मार्क ईच बेसिकली। and the time allotted for this computer knowledge section is 15 मिनट्स। आपको 15 मिनट मिलने वाले हैं। ये आपको सेपरेट 15 मिनट्स मिलेंगे। थोड़ा सा कहीं ना कहीं टफ हो सकता है क्वेश्चंस थोड़े से बड़े आए, आपको पढ़ने में टाइम लगे। तो तैयारी कीजिए बढ़िया करके गाइस, ठीक है। तैयारी बढ़िया कीजिए। हम आज इसी कंप्यूटर नॉलेज के सेक्शन में आगे बढ़ेंगे। हमने प्रीवियस एक क्लास कर चुके हैं। आई होप आपने देखी होगी, नहीं देखी होगी तो हमने हमारे चैनल पे आप देख सकते हैं इसको। प्रीवियस कल ही क्लास हुई है, आप जाके एक बार उसे चेकआउट ज़रूर कीजिएगा। आज की क्लास में आगे बढ़ेंगे गाइस और थोड़ा सा जानेंगे क्या क्या होने वाला है। सो लेट्स गो अहेड गाइस एंड मूव टू द क्लास। सो इंटरनेट एंड नेटवर्क प्रोटोकॉल्स, क्लास सेकंड। So we are going to talk about reference models, OSI model, TCP/IP model, difference in OSI and TCP/IP, what is IP addresses, what is IP protocol, and the other network protocol, guys. Okay. In the previous class, we have talked about reference models and OSI models. That is completed. If you didn't see that, then you can check our previous class. Don't worry about that. It was live yesterday. So now let's move ahead to TCP/IP model. What is TCP/IP model? Let's understand that. So TCP/IP model was developed prior to the OSI model. So as you can see, like first there was TCP/IP model, then ISO developed OSI model, right? The TCP/IP model was generated earlier than OSI model. The TCP/IP model is not exactly similar to OSI model. Remember it. TCP/IP model is a little different than OSI model, guys. Okay, this is very important. What are the differences? That part will be important. The TCP/IP model consists of 5 layers only. Okay, remember that it has 5 layers: the application layer, the transport layer, network layer, data link layer, and physical layer. The 5 layers are the application layer, transport layer, network layer, data link layer, and physical layer. Basically, the 5 layers, the name are resembling similar to OSI layers. There are two basic layers which are not available in TCP/IP model. We are going to talk about that in a few minutes, but still, please be with me and let's understand what is the history of TCP/IP model. Okay. The first 4 layers provide physical standards, network interface, internetworking, and transport functions that correspond to the first 4 layers of the OSI model. And these 4 layers are represented in TCP/IP model by a single layer called application layer. So in the OSI model, there was first 4 layers like application layer, network layer, and so on, like right, presentation layer, and so on. So all those layers combined is application layer in TCP/IP model. The seventh layer, sixth layer, fifth layer, and fourth layer, like combined, is application layer in TCP/IP model. We are going to understand it with the diagram in a few minutes, guys. So TCP/IP is a hierarchical protocol made up of interactive modules, and each of them provide specific functionality. Now, this line is important. You have to understand this. Okay. थोड़ा सा समझेंगे. TCP/IP is a hierarchical protocol. So it is a hierarchical approach. Okay. Something like this. This is called a hierarchy. First layer, second layer, third layer, fourth layer, something like that, right? Made up of interactive modules. So these modules interact with each other. Remember that in the OSI model, the layers were individual. They were not interacting with any other layer, right? They were providing the services only. But in TCP/IP model, the layers are interacting with each other, and each of them provide specific functionality. So each layer have their own specific functionality, right? Just like OSI model. Now, let's talk about the history of TCP/IP model. This is important because there are some changes in TCP/IP model with the time. So, when we talk about the TCP/IP model, it was designed and developed by Department of Defense. So, OSI model was developed by ISO, International Bureau of Standardization, right? Okay. But the TCP/IP model is developed by Department of Defense, DoD, in 1960s, like prior to OSI model, and is based on standard protocols. So it is based on some standard protocols. They are not creating any new protocols, or they didn't create any new protocols. They just took the standard protocols and create a model with that. Okay. So it stands for transmission control protocol and internet protocol. So the full form of TCP and IP is transmission control protocol and internet protocol, guys. Remember that. The TCP/IP model is a concise version of OSI model. It contains 4 layers, unlike 7 layers in the OSI model. The layers are okay. So here you can get a confusion like, sir, previously you were saying there are 5 layers, now you are saying 4 layers. Yes, the original model of TCP/IP had 4 layers. Okay, remember that the original model, which was developed through DoD, it has 4 layers, the original model. Okay. And the second version have 5 layers. Okay. So the original 4 layers were process or application layer, host to host or transport layer, then internet layer, then network access or link layer. So these are the 4 layers in original TCP/IP model. Okay. We call it application layer nowadays, but it is process layer back then. And host to host layer becomes transport layer, internet layer, and network access or data link layer, basically, right? So quite familiar. These are the original 4 layers available in TCP/IP model, guys. Okay, remember it. Now let's move ahead. Let's understand some things about the changes which has been done by DoD or ISO and so on. Basically, the need of the changes were there. So the original TCP/IP network model started with 4 layers: the application layer, transport layer, internet layer, and link layer. But the second version, which we are using right now, of TCP/IP becomes 5 layers. Change the name of the internet layer to network layer. Internet layer becomes network layer, guys, and divided the link layer to 2 layers. And the link layer got divided into 2 layers, guys. It becomes application, then transport. These are similar, right? These are similar. But internet layer become network layer over here, and link layer divided into two parts, data link layer and physical layer, right? Remember it, guys. Application is application layer, transport layer is transport layer, internet layer becomes network layer, and link layer become data link layer and physical layer. Okay, so you have to remember that what are the changes in TCP IP model. There can be a question like that. The uh, link layer is changed into dash and dash in the newer version of TCP IP, right? The questions can be like this. Okay, let's move and understand some other parts. So if we take a pictorial representation of this, so we can understand it better. Let's say we have TCP IP model and OSI model. We are comparing the original models, guys. Okay, we are comparing the original models. Remember that application layer is here, right? Then transport layer is here. Internet layer, that is the network layer, right? And network access layer, basically this becomes this, right? So the application layer, the first layer in TCP IP model becomes these, right? So application layer, presentation layer and session layer all combined together are application layer in TCP IP model, right? It is TCP IP model. It is application layer in TCP IP model, guys. Okay, remember that. I hope it is clear what is the pictorial difference between TCP IP model and OSI model. Basically, layer based difference. What layers are not present is these two. These two are missing in TCP IP model, presentation layer and session layer. The all work of presentation layer and session layer is done by application layer in TCP IP model. Okay, remember that. Okay, let's move ahead and understand the differences between TCP IP model and OSI model. Okay, these differences can be important. Okay, now TCP IP refers to transmission control protocol and internet protocol. Okay, OSI, open system interconnection. I hope that is clear. Now TCP IP has 4 layers and OSI has 7 layers. We are comparing the original models. Okay, we are comparing the original models. TCP IP is more reliable and OSI is less reliable. It can be important. Okay, now TCP IP does not have very strict boundaries. OSI has strict boundaries. We are going to talk about it in a few minutes. Okay. TCP/IP follow a horizontal approach. Okay. TCP/IP has horizontal approach. So if we have layers, let's say application layer, then let's say transport layer, network layer, and data link layer. So data flows horizontally, right? And OSI follows a vertical approach. Vertical means it flows data downwards. So we have application layer, then we have presentation layer, then we have session layer, then we have transport layer, and so on. So data flows downwards, okay, or upwards. It is a vertical approach, and TCP/IP is a horizontal approach. Okay, remember it. That can be important. So TCP/IP uses both session and presentation layer in the application layer itself, right? As I told you, the session and presentation layer, all work of these layers is done by application layer itself, right? OSI uses different session and presentation layers. So it has different session layer and presentation layer. TCP/IP developed protocol then model. Okay, this is important. OSI developed model then protocols. Okay, this is important. So back then, when there was a need of a model for communication, like when it was the time of World War, at that time when they were using computers to transmit the data, they felt a need of a particular model by which they can communicate, right? So they created the Department of Defense. That's why Department of Defense is there in the creation of TCP/IP, because it was the time of World War and they were trying to communicate with each other through the computers. So they need a particular model for communication, right? So at that time, the protocols were available. So they merged some protocols and created TCP/IP model. Like there were some standard protocols, they took them and create a model with it. But later, they felt like the TCP/IP model is not that appropriate for work. So they, like, imagine a new model, create the fundamental things, like imagine all about that. Then they lay down a graph or a blueprint of that particular model. For that model, they create special protocols, right? So OSI developed model, then protocols. So they create a blueprint of the model, then they created the protocol according to their need. But in TCP/IP, the model was needed because it was the time of World War. That's why they use the standard protocols for the model, guys. Okay. So transport layer in TCP/IP does not provide assurance delivery of packets. So in TCP/IP model, the transport layer does not provide the guarantee of delivery of packets. But in OSI model, transport layer provides assured delivery of packets. So in TCP/IP, they does not guarantee the delivery of packets, but in OSI model, they guarantee the delivery of packets. Okay. TCP/IP model, network layer only provides connectionless service. In TCP/IP model, the network layer only provides connectionless services. It is important. Which layer is responsible for providing the connection oriented or connectionless services? So it is network layer, guys, right? It is network layer, right? That can be important. And connectionless and connection oriented, both services are provided by network layer in OSI model. So in OSI model, the connectionless and connection oriented, both kind of services are possible. There can be a similar question like which layer is responsible for providing the assurance delivery of packets. So transport layer is responsible for the assured delivery of packets, right? Okay. Now protocols can be replaced easy. Sorry, protocols cannot be replaced easily in TCP/IP model. So in TCP/IP model, the model was created later after the protocols are there, right? So first we have protocols, then we created a model. That's why it is very difficult to change the protocols in this model. But while in OSI model, protocols are better covered and is easy to replace with the changing technology. So if we are using OSI model as a reference model, in this kind of model, the change of protocol is quite easy because layer have their own particular work. They doesn't depend on other layers. So it is easy to change a particular protocol in a layer, right? So these are some differences between TCP and IP, guys. Okay, let's move ahead and understand IP addresses. Okay, what is IP and IP addresses? So an IP address represent a unique address that distinguishes any device on the internet or any network from another. We are talking about IP address. Okay. We are talking about IP address. We are not talking about IP. IP is internet protocol, but we are talking about IP address. Okay. IP address is a unique address that distinguish any device on the internet. Okay. So if you have any device, suppose that you have a smartwatch, you have a smart bulb, you have a smart TV, yeah, or there can be a smart AC, smart locks, anything which is connecting to the internet, it should have a IP address. Okay. So IP, now we are talking about internet protocol. IP or internet protocol defines the set of commands directing the setup of data transferring through the internet or any other local network. So there is a difference between IP address and IP. Understand it. IP address is basically an address like you have your address of your home or your PG or something like that, right? By which you can like send something or you can like receive something on that address, right? Similarly, your computer have a IP address. That address is used to send the data or receive the data, right? Suppose that you are sending a letter to your friend. So you need the address of your friend, right? Without the address, you cannot send that letter. Similarly, if you want to send some data to your friend, so your computer needs its IP address, right? To send that data, right? Okay. Now, IP, what is IP? IP is basically Internet Protocol. It is a set of rules by which the data should be transferred. Now, if you are sending the data, will the data be sent in a single row or a single wire? No. Your computer is connected to a Wi-Fi, right? Then that Wi-Fi is connected through a ISP server, and that ISP server have multiple lines connected through it to every server. So, to which path your data should go? That's why we need a protocol. Basically, what a protocol do, it arranges the data with your sender address, receiver address, and many other things. Okay. So a protocol sets up this kind of particular packet. The data, the sender address, receiver address, checksums, and many other things are there. And this particular format will be read by that particular protocol. That's why we need a protocol, right? It is like you write a letter. Suppose that basically there will be like from, then you will like, let's say you will write to dear friend something, then your letter, then from, right? That is a particular format of writing a letter. Similarly, your data should be in a particular format to be read by the another computer, right? So an IP v4 address is a 32-bit unique address having an address space of 2 to the power 32. Okay, so this is important, guys. This is important. Remember it. This point is very important. What is the size of IP address? The size of IP address is 32-bit. Okay, the size of IP address is 32-bit. Remember it, and it is a unique address. Okay, and the total address spaces is 2 to the power 32. The total devices that can acquire a IP address is 2 to the power 32, guys. This many devices can acquire a IP address. Okay. Only this many devices can get a unique IP address, not more than that. Okay. Remember it, guys. It is an important point. So that's all for today, guys. And we will talk about uh, basically this is a smaller number. Like this is a smaller number and devices are more than that. Even in India, you have more devices than this. So there is the addresses, unique addresses, like they are very less and we need more addresses. That's why we are having IPv6. Okay. Now we have IPv6. We will talk about it in the next class. But right now, understand this. The size of IP address is 32-bit and the unique addresses that it can create is 2 to the power 32 addresses. Okay. Remember it, guys. So that's all for today. I hope you enjoyed this class. And if you do, then give it a big thumbs up and don't forget to share and subscribe our channel. And yeah, the link of the courses is in the description. Please check out it once. And if you want any help, the WhatsApp number is also available in the description. Please check it out. So that's all for today, guys. I will meet you in the next one.